Okay, we're going to be looking at problems 30 to 32 on page 505 and 506 from chapter 9. Problem number 30 talks about a t-distribution. And remember, a t-distribution is somewhat like a normal distribution or a z-distribution. However, if the z-distribution looks something like this, something about like this, your t-distribution is going to be the same thing, that's just a little bit heavier tailed. So it's not going to have as much data in the middle. It's going to be a little bit heavier tailed, still unimodal symmetric, still should be centered in the same location, but the t-distribution is going to have more data in your tails. The whole point of a t-distribution is it's for estimating the sample mean, or x bar. If you know sigma, you can use the z-distribution. So if I know sigma, I'm going to use the z-distribution or the normal distribution. If I'm estimating the sample mean, when I don't know sigma and I'm having to estimate it with a population standard deviation, that's when I'm going to use my t-distribution, which is pretty much unimodal symmetric, but it just has more data in the tails. It has more data in the tails because estimating your sample standard deviation, using your sample standard deviation to estimate that population standard deviation is going to increase your variability and make your data spread out a little bit more from the mean. Now to get number 30 complete, you could do this using the table that's provided on the back of your formula sheet, but I'm going to show you how to do this with your calculator. With your table, it's just a matter of looking it up correctly. But to do it with the calculator, what you can do is you can go to second distribution, and the first one gives you a range that wants to know what value falls within that range. So I'm going to go to CDF, option number 6, and I'm going to put in the lower and upper regions. So the lower is negative 1.84. Negative 1.81. The upper is positive 1.81. Then it does ask for degrees of freedom. In this case, it just gives me the degrees of freedom of 10. And then I'm going to paste this in, and that gives me the answer. So basically, I would be looking at the middle 90% of my distribution. Looking at the sketch we made of a t-distribution, if you had a t-distribution like this, although it is slightly heavier in the tails, it does make sense that if I'm looking for the middle 90%, I would still get it if I was between negative 1.8 and positive 1.8. I would still get the middle 90% of my distribution roughly. Okay, just to do one more of these, I'm looking at the next one with part C, 24 degrees of freedom. Part B, looking from negative 2.23. I just go back to my distribution. And TCDF option 6. And this time do negative 2.23. Since I'm going, this does mean between negative and positive 2 standard deviations from the mean. Even though this is a t-distribution, as you go further from the mean, we would expect to capture more of our curve just like normal. I have a syntax error. I need to be sure I use my negative symbol and not a minus. And then that's going to give me 0.95. So roughly 95% of your data is in that range. Now you do notice with a normal distribution, it would have been about 1.96 would have been your critical value. With this t-distribution with 10 degrees of freedom, my critical value to capture the middle 90% has spread out. That is an example of how there's more variability. When I look at number 31, in this one it wants to find a critical value. So since I'm starting with a percent, I can use t, inverse t will allow me to start with that percent and come up with the data I need. So just to sketch what this would look like, if I'm looking for the middle 90% of this distribution, I'm trying to cut off, well, it's wanting 95, so I need to go out a little bit further maybe. If I'm cutting off the middle 95%, what's important to know is there's a total of 5% in both tails, so that means there's 0.25 in this tail and 0.25 in this tail. And for inverse normal, we're always going in terms of less than, so I'm looking for the area of this tail here. So what t-score, what critical t-score will cut off that part of my distribution. So what I'm going to do is I'm going to go back to a distribution, and I'm going to do inverse t, and I'm going to use the 0.025 for my tail area, and then my appropriate degrees of freedom. In this case, it says my sample size is 17, so my degrees of freedom is always one less than my sample size. When I estimate that sample mean, I lose one independent statistic, so when you're dealing with sample means, your degrees of freedom is always one less than the sample size. So sample of 17 degrees of freedom is 16. Press enter a couple times, and it gives us a critical t-score of negative 2.11. So that would be my t-score that would cut off that part of the distribution. Now, sometimes they don't put the negative because this side is 2.11, but on negative 2.11, but on the upper side it's positive 2.11. And in your confidence interval formulas, you'll have pluses or minuses anyway. That's why usually they're just going to write the answer without the negative. But I would take it as correct either way. Last but not least, I'll do part of number 32. Number 32 actually gives you a confidence interval. And it says that the confidence interval goes from 114.4 to 115.6. And the first thing it wants to know is, what is the mean value? Well, since a confidence interval is always your statistic plus or minus your margin of error, you can find the mean, since you're adding or subtracting the same value, the middle of this confidence interval is always your mean. So my mean value, my sample mean, is always going to be smack in the middle. So I just need to average those two numbers with my calculator. So 115.6 plus 114.4, add them up, divide by 2. That tells me my mean is 115. So my estimating X bar would have had to be 115. And the margin of error would have been, for this one, 0.6. Now, the second part asks which one had the was 90% and which one was 99% confident. Well, when I look at my two intervals, my second interval is from 114.1 to 115.9, which is somewhat wider. And to have a wider interval, when your interval is wider, that is going to make you more confident in your answer. You basically can be more confident that that interval will capture that that an interval of that width would capture your statistic as the interval gets wider. So the wider interval is the one that I can be more confident in the method that produced it. So that's going to be a 99% confidence interval for that one, and only the 90 for the other one.